Good afternoon, ladies and gentlemen. Thank you for joining us today. Our event will begin shortly. We're just waiting for some more dialing in, and we appreciate your patience. Just give us one or two more minutes, please. Good afternoon, ladies and gentlemen, and welcome to our webinar today. I'm Joni Utesh with Adaptive Corporation, and our presentation is titled Inspection Planning with CATIA V5. Today's event is focused on offline programming for CMM and CATIA V5. Your presenters today will be Frank Thomas and Larry Keene of Adaptive Corporation. At the conclusion of our webinar, the presenters will be taking questions from the audience. To ask a question, please enter it in the GoToWebinars chat window at the bottom right-hand corner of your screen. We're now ready to begin, and I will hand it over to you, Frank.
Okay, very good, Joni. Thank you. Okay, so let's go ahead and get started. In terms of the webinar today, just wanted to take a minute and review the agenda. We'll be talking briefly about some takeaways. So there are specifically 3 things in the webinar today that we plan to highlight. And our goal is that, if nothing else, when you come away from the webinar today, these are the 3 things that we hope that have value with you and that you get to see as part of the live demonstration. We'll go through just kind of a brief overview of what the solution is. Larry Keene will be joining us to provide a technical demonstration. Then we'll close out with just kind of a brief review of what we saw, and allow time at the end for some Q&A. Altogether, the webinar today should take something like 40-45 minutes, and that should allow plenty of time for any questions that you might have at the conclusion of our webinar today. We have a couple of polls today as well to better understand our audience. We'll be sure to share the results of the poll. I think you might find them of some interest as well. So maybe, Joni, at this point, if you would show our first poll, please. Okay. So the first poll is, what is your role within the organization? And wondering if all of you would just kind of take a moment and just kind of click on, what your role in the organization is. Again, the goal here is just to kind of better understand our audience, so that if we're talking primarily at quality people and we use some terminology or vernacular that might be a little bit unique to that group, at least we'll be comfortable, because we know that most people are quality, or if you are some other role, that would be helpful to know as well. So we'll provide about 10 seconds to see the results of that. Joni, if you could now show the results. So I'm having a hard time reading the results.
We've got the QA manager, we've got 19%, inspector about 50%, Frank, and the NC programming 31%, and other 38%.
Perfect, perfect. Okay, great. Thank you, Joni. So let's go ahead and move on then to our takeaways. Again, I mentioned that there are 3 takeaways that we'll demonstrate to you as part of the webinar today. Our first takeaway is that we want to validate against native CATIA data. By virtue of operating this solution natively in CATIA V5, there is no data translation. CMM programs are fully associative to the 3D model. If you change a whole location, for example, the CATIA V5 CMM planner will automatically update the CMM program to reflect the changes. Our second takeaway is supercharge your MBD. MBD stands for model-based definition. This solution works directly on the 3D model. The programming process references the master model in CATIA V5. There is no need to translate or create other 2D drawings to tell your CMM program what to measure. Since I'm working in the 3D environment, I can see that all model-based definition information that needs to be taken into consideration when generating the CMM program. The V5 CMM Planner creates a production-ready program that runs natively virtually on any CMM hardware. And our third and final takeaway is leverage existing hardware and software. I think that this is a pretty big one. Implementing CATIA V5 CMM Planner does not require changes to your existing hardware or software. Your CMM operators do not need to be retrained by virtue of implementing the CATIA V5 CMM Planner. We post the CMM program in the format that is native to your current CMM software that is currently driving your CMM machine. So at this point, Joni, I wonder if you would display our second poll. And our second poll is basically asking, how are you being asked by your customer to validate parts? I wonder if everybody would take a moment to answer this question. We'll give them about maybe 10 seconds, and then we'll show everybody the poll results here briefly, because this oftentimes shows some interesting results. Okay, let's show the poll. And Joni, if you could read the poll results to us, please.
From supplied model is 17%. From supplied 2D drawing is 6%, and the combination of both is 89%.
Okay, great. So it's interesting that it's a combination of both, which is exactly what we would have expected. You know, everybody is trying to work and do their job with what we've got and the information that we're getting from our customers. We have one last poll that I'd like to ask Joni to show now, because that'll impact some of what we highlight here in the balance of the presentation. And the poll is basically, are you using IGES or STEP to connect with your CMM today? So kind of curious, you know, some people have purchased upgrades to their CMM software so that they can import native CATIA or native SolidWorks or whatever the case might be. We find that most people are using IGES or STEP and looking for some feedback here. And if we can show those results.
We have 82% yes, and the rest no.
Okay, so it looks like a majority of everybody is using some combination of IGES and or STEP to communicate with the quality department from engineering. Okay, so with that, I'll turn over this part of the presentation to Larry Keene, that will then follow on with the technical presentation. Go ahead, Larry.
Hello, everybody. My name is Larry Keene. This product that we're about to see is a kind of a predecessor to a V4 product that some of you might have heard of called CAT CMM. The main thing about this is that it works native in V5 CATIA. So everything is working from the solid model, engineering model supplied to you by your customers. So the first slide, the V5 Planner overview, like we kind of said, eliminates translation, supports MBD, improves efficiency, eliminates error, flexible post-process, are easy to learn. And we'll kind of talk about that as we go along. Next slide, Frank. Eliminate translation. So we're working native with the CATIA V5 model. We eliminate the whole process of engineering, creating IGES and STEP files. We do not have to create IGES and STEP. We open up CATIA and work with the native model. And like Frank said, we're fully associative. If we roll from a Rev A to a Rev B and a hole moves, our inspection plan automatically updates. So our CMM program is completely associative to the latest CATIA model that we're working on. Slide. Supports MBD. one of the big problems with IGES and STEP is we're losing some of the information that an OEM may have had in the native CATIA model. What I mean by that is it's called FTNA, Functional Tolerance Annotation. So if an aerospace supplier sends a CATIA model and it has the MBD in it, or the GD&T or the FTNA, if you create an IGES file, you're not going to see that if you import it into a CMM program like Virtual DMIS or PC DMIS or one of these other CMM softwares that do not support the CATIA. So being that we're working in the native engineering model, we get to work with the MBD supplied by the OEM. It improves efficiency. We're eliminating translation, so we do not have to have the engineering department create IGES and STEP files if the programming department or the CMM department does not have CATIA. We get quick graphical feedback on our program, and we're going to see that when we write a program and we play simulation. It's a one-click measurement to create program 5-axis holes, 2D holes, or if your model has points and vectors only. A lot of times old V4 models from Boeing used to just supply a point and a vector. We can handle that. And we can lay our points down exactly the way it might be specified on a drawing. In other words, we could use section planes and engineering reference points to put the points on the model exactly. So it's very fast to create holes, and we could put exact engineering points on the model and on our CMM program. Eliminates error. We don't have to worry about an IGES translation and a wrong surface being measured because we're not doing that. We're able to work, the product works inside a CAT product. So if you want to bring in your holding fixtures, if you want to model hold-down clamps, anything else that might be relevant that is sitting on the CMM, that could be in your inspection plan graphically, so we can eliminate collisions and don't have to worry about that. So the error is in the program created. We can eliminate that. Flexible post-processor. The concept of this product is you create your CMM program in native V5 and you post to probably one of the more popular softwares is some flavor DMIS. And you can see on the screen here we support a lot of different DMIS flavors and some older CMM software. So the goal here is you do not have to change out your CMM controller. You do not have to change out your software. We create data that's ready to open and run on in your environment. And the biggest savings to this, besides the changing out software and controller, is the CMM operators do not have to be retrained because they're working in software that they've been working with for years and they know. It's easy to learn. It's CATIA. CATIA is almost becoming a standard right now in aerospace and automotive. So a lot of you already are using CATIA. You don't have to learn anything new. This product will work on a bare bone seat of CATIA. You do not have to have a high-end manufacturing seat. It'll work on what we call CAT seat, which is CAT Express. So it'll work on a bare bone seat of CATIA. At this point, I would like to start the demonstration. What I have on the screen here is a typical aerospace part. So everybody should be seeing my screen right now. Frank,
yep,
are we seeing the
Go ahead, Larry. You bet. Go ahead.
So what we have here is a typical aerospace part, 5-axis machine part, contours. We have MBD information in the part with the profile tolerance and true position tolerance. We have a datum structure in the part, datum A, datum C, datum B. A big takeaway on this is being able to, a lot of times when you IGES models out of CATIA, it always comes out in aircraft space. So it always comes out in Axis System 1. So with the V5 planner, we're able to create a local datum structure based on what the supplier or OEM gave us. In this case, they gave us datum A, datum B, and datum C, so we're able to create a coordinate system on the model called CMM. And we'll be able to use that information to program the part. And then if we want to post out, we can post out in aircraft space, or we can post out in a local space. We can even utilize NC axes. So if you cut the part in CATIA, and you have a certain NC axis, we can program the CMM from that NC axis. And so at this point, we will copy the part and we'll start inspection. And we'll paste the CAT part into a CAT product. And the reason we chose a CAT product is now we can work with assemblies and we can work with tooling, things like that. So we'll get in here. We will start a plan. We'll call this Demo 1. It's prompting us to pick the axis that we want our plan to come from. We'll pick this local CMM axis, and it's prompting us to align the CMM probe to our part, and we'll use the same axis, and we'll say OK. And then in CATIA, we started a plan. So the first thing we made on the top right, or in the far right, we have a lot of motion controls, and on the bottom we have a lot of inspection information. We'll start out by putting a comment in here, and we'll say, we'll send this to a report, and we'll say inspect KC points. So we'll inspect some critical characteristic points that came over with this model. So we put a comment in. We will start out by putting the machine in DCC mode. We can put manual tolerances in, so we'll put some tolerances to get started. We have a clearance plane. We'll have the clearance plane off. We can put approach and retract information in here. Here we'll put 050 because we're going to be measuring these holes later, but this is all CMM kind of stuff that needs to be in the machine when it runs. And we'll also put, oops, hitting the wrong button. We'll also put a go-to move into the program, and we'll set it at 1/4 inch every time. It comes in part or it takes a point. So all this information is kind of setting up our how the motion of the CMM is going to work. And now we'll put a start go-to move in. So we'll go to 003. So now we get to see the probe. Going back to that, we can see that the probe is built. We have post-processor settings for doing mirroring and some custom DMIS type stuff. And we have a probe builder. So you can build the probe that you're using and save it off in a library. So we'll go back to where we were at. So that probe was just kind of a standard Renishaw probe. And we will come over and we'll actually do a go-to move. One of the really powers of this is we're working inside CATIA. We get to take the benefit of planes and information in the model. So we just indicated a go-to move on a plane inside CATIA, and we will inspect these points that were supplied by the OEM, and they were called key characteristic points. So these points right here, the OEM wants those points measured. The real big thing about this is we retain the names of the points, and we can measure those exact points. So by clicking this button right here, it's keeping the CATIA names. Otherwise, you could give them different names. So what we'll do is we'll pick this surface. We want to approach it from this side, and we'll pick these points and say OK. We'll turn the name on the points, and you can see they come in, and we can reorder these points. I wasn't sure which one was what, but we retain the name of these points. So when you post this out to PC Demas or Virtual Demas or Caps and Edges Demas, Cameo, things like that, these points will be named the same thing, which are real important for model-based definition. So that's one way that we can put points on the part. We'll come over here. Let's say that we want to measure this contour right here. We'll do another go-to point. On this plane, bring the probe over to here. Let's say that we want to align the probe to that surface. We can hit this button here, pick that surface, and it's telling us what the angle should be on that. We can change the probe angle, so we just align the probe to that. We can go back to I always big in going back to where it came from when you do a probe change, so now we're aligned to that surface. And these planes right here could be put in, they're section planes or station planes that the customer wants your part inspected to. So we have a tool for that. We can pick this button right here, and we can say we want to put 10 points. We can pick that surface. We want to approach it from here. We want to cut that plane. We want to say preview, and it's showing that we're going from the bottom to the top, and we can say OK. So now those planes are called slice. And those they can have any name you want. So we'll pick that again, and this is where that name is coming from. It can be any name that you want to have. We'll pick that surface, select the vector. This time we'll pick the other plane. We'll preview it, and they're still going up. We can reverse that, so now they're going up and then going back down. We'll say OK. The real big takeaway to this is you could see that these are exactly station points. So this was on, sometimes you hear it called waterline, butt line. These are on exact station cuts that were supplied by the OEM. So we have points at 11 inches and 12 inches. So that's real big for like when you're inspecting spars or bulkheads, things like that. So now we just program that. Now we want to show you another way to maybe possibly measure some points. So we'll go back. We already have this go-to move that we use, so we can go back up to here. If we want, we can key in a probe angle. Oops. We can key in a probe angle. We can say at any time we want to go back to 0. So you can pick angles or you can pick the model. And we're going to inspect this surface right here, and we have some more planes that we want to cut that part from. And you can see you can't really align the points to the UV. We want to align our grid of points to these planes. So we have another feature that we could use, and we can pick this, and we can say we want to put our points 1 inch in this length direction, and then we want to go 1/4 inch in this direction. So we can we can set our name, so we can call that upper OML. We can pick our surface, set the vector. We can say we want our 1 inch grid coming from here and our 1/4 inch grid coming from here. We can do a preview. If we want to put more points, we could change that at any time and say, nah, I need more points on there. I want to do a preview. That's too many. Let's go to the 1/4 inch. So we have full advantage of all the CATIA functions, and we can say OK. Okay. And again, if you want to make what we call roadmaps for showing, that's a big part of model-based definition inspection is a roadmap. Then you could do plots or screen dumps, things like that, showing where all your points are at. So we keep all the names of the points, and they correspond into our plan, which corresponds when we post the data out. So there's several ways here of creating grids of points. We can do simple indicating of points. So if we wanted to put a few points on datum A, we could come in and we could say, let's inspect that A. One real common way that inspectors like to create point times are just indicating points. So we can come in here and we can say A, we could pick the surface, set the vector, and we literally can just use the mouse and we can randomly put points on. So easy way to create points. You can see those points are all on Z0, which is datum A. Okay? So now let's say that we want to measure holes. I want to change a setting just so when we do our replay, everybody can see what I did. I'm going to change this setting, and I'm going to put it so you can really see the move. I'm going to put it at 1 inch. So every time it goes out of a hole, it's going to lift up to 1 inch. And let's say you might have a clamp right here. You might have some clamps, so you know by lifting up to 1 inch, you're going to be able to clear the clamps. We'll come into this hole. So we have 2D hole, we have 5-axis hole, and point and vector hole. Then inside the strategy, so we'll call these holes, inside the strategy, we're going to probe the hole 4 times. We're going to go down into the hole 30 thousandths. We don't need to probe at a second depth. And then we have these strategies. We can create what we call where we'll create exact hit points based on the PT measures, or we could create an auto hole which lets your software so you have settings inside your software for clearance, plane, depth, things like that. Or we can do an R measure hole which probes the face of the surface and then adjusts down to the exact depth. So we have program mode, auto mode, or vector mode, or R measure. Different people call it different things, but there's 3 strategies in probing a hole, and then we can do inside or outside diameter. So for this case, we'll do an inner diameter, and we'll set the 4 hit points. All you basically do is pick the curve, reverse this. That shows you the strategy. We're down 30 thousandths. We're going to approach it from the top as fast as you can pick the hole. And you can reverse these all at once if you want. I could have picked them all and then reversed them, which I probably should have done. Those are all 2D holes. We'll say accept. So inside the plan, what it's doing is it's extracting the XYZ, the IJK, it's pulling the 125 diameter, it's titling the holes. And then if we want to measure 5-axis holes, we can come in here and we can say, I want to align the probe. So I know I'm going to lift 1 inch already above the hole, so I don't have to worry about that. I could pick this button, and I could pick the hole, and I can align my probe best to that hole, okay? And then I can pick this, and we'll keep the same here we'll call it KC holes maybe. We want to probe it, we could probe 2 depths if we want, so we can go down 20 and let's go down 40 because we want to make sure the vector's right. We can go back to 4. We pick the cylinder wall of the hole, reverse the vector. These 3 and say OK. So now we end up going to be probing these holes in 2 spots. So we go through the part. One more thing that I want to show you is points along the edge. So we go through the part, we program all the holes and the surfaces. The thing I want to show is putting points along the edge. Forgot about that. So we'll move the probe over to here. We have another really slick way to put points along the trim of the part, and it's this icon. So we want to put 5 points. We're going to call these points trim. We're going to pick the model. We're going to say we want to come from outside here. We pick the edge. We're going down 20 thousandths, and we could say preview. We want to reverse that direction. So we're going to go from here to here, and we could say OK. Then we could do that again. We could say that. So let's say this time we only want to go 3 points. We can say preview, reverse the direction, say OK. So now, I don't know if anyone caught, but I kind of made one mistake here. I should have changed my approach and retract a little bit. So at any point, I could come into here, and I'm going to go back in here, and I'm going to say that I want to move that back to a 1/4 inch. So I don't have to go back and redo it. So now, after each point, it'll be a 1/4 inch, and I need that to get around this corner. So you can go around the part very fast and create your profile or your trim points. So you go through your inspection plan. You know, a part like this should take maybe a ½ hour to go through the plan, and you want to prove that you did everything correct. At any time, you can say you want to simulate what you did. So you want to simulate, and this really doesn't matter because it's the same simulation because it's just going to simulate the posted process. But I want to simulate virtual DEMIS. I can set the speed I want. I want to show the trace, and I'm going to say load simulation. This is very similar to what's in CATIA NC, and I can say play. So as we're watching the screen, there's our 1/4 inch moves that we did. We changed that probe angle. Now it's probing these points. We'll let this play up until where we set the 1 inch so you can see the difference. And we have different speeds here. So you could set it 1 through 10 times to adjust the speed. This is very important if, let's say, a CATIA NC guy writes a program for the CMM department, or somebody in a different room creates the program. He gets a really good feel that he's not going to be inducing any kind of crash. So right here, this is going to take a little while. So maybe I'll stop that. But what we would have saw here is when we got to the 1 inch, the holes, it would have lifted up a 1 inch instead of what you're seeing right here. It's lifting a 1/4 inch. That's a 1/4 inch. It would have went up to 1 inch. So we could stop at any time we want. So we run our simulation. We see everything is okay. We're happy with that. If we wanted to, we could go in and we could edit this information by right-clicking. There's editing capabilities. Okay. And another time that you can simulate too is anytime you pick something in the edit window. You could walk through with your keyboard and simulate this way too and see exactly what you're doing. So I can walk through a simulation this way too. Go into the different holes. So you're happy with your program. At this time, we want to post-process this for our CMM, to give it to the CMM operator. We're going to come up here. We're going to hit post-process. We're going to post-process the demo file. We output an app source file. Some of our large OEM customers use Vericut, and they wanted to simulate to do their collision detection using Vericut. Any NC programmer on this call will know exactly what I mean. There's a good chance you use Vericut if you're programming in CATIA. We also create the inspection plan. Years ago, we used to call this at Northrop QA data, Quality Assurance Inspection Data. McDonnell Douglas used to call it QPAS, but it's the key characteristic is the inspection plan. So we want to post this, let's say, to virtual DEMIS. We're going to browse to where we're going to post it. So I'm going to say, let's put this to C. I got a post file down here, and we'll call this demo1.demis. We post this out. We go in here. We go into the file. The first thing that we created is the inspection plan. And for your NC programmers that do things in NC, you're used to seeing this. This is the coordinate system that the CMM axis came from, that the aircraft space. We have some tolerance information and all of our names of our points, X, Y, Z, I, J, K, and you can see how we named all the different points, different things. On holes, we get some more information. We're extracting the diameter, the depth, how many times we're probing it, it's an ID, things like that. We also created an app source file. We have customers that take this data and turn it into G-code if you want to do on-machine probing. So we have customers that like to do on-machine probing from this. This will also go right into any CATIA NC process. If you wanted to simulate and do collision detection in NC process, like I said, this will also go right into Vericut. And then finally, we create the inspection DEMIS plan. So all you CMM guys will understand this. These are the point measurements. It keeps the name in here, the tolerance information that we put early in the program, our approaches and retracts, these outfile statements that go into your report. Later on, as we measure the holes, here's where the holes are. These are the PT measure hits in holes. And then when we did the holes at 2 depth, what we ended up getting is we had 2. So this was the top hit, and this is the bottom hit. And we could even construct a line from the bottom and the top if you want to see what the vector is. But we're probing the top of the hole and the bottom of the hole. So this is our DEMIS. And then depending on the different CMM software, Virtual DEMIS likes to have an external tip file. So these are the probe angles that were created. I can open this in Virtual DEMIS and hit execute. They automatically calibrate. In PC DEMIS, these angles are kept at the top of the DEMIS statement. When you open up the DEMIS, it'll say these probes are not calibrated. You want to calibrate them at this time. You say yes, and they go calibrate. So depending on the post processor, the tip files are in a different location. That kind of concludes our demonstration part of the CMM planner. So at this point, I'm going to give it back to Frank on the PowerPoint.
Okay, very good. Thanks, Larry. So let me see. Joni, if you could pass it back to me, please.
There you go.
Okay. Okay, so everybody should be able to see my screen again. Okay, so to just kind of summarize some of the benefits of what we saw today, and then we're going to open this up to Q&A here in a minute, because I know that I've got half a dozen questions that have hit me from people typing in questions on the chat window. And by the way, if you do have any questions, it's still not too late. Go ahead and type in the question in your chat window. Joni will read off the questions. We'll take some time here before we close out the call to make sure that we get as many of your questions answered. So to summarize, from a benefit standpoint, you know, many people have a challenge of managing translated data, because now we're trying to minimize the amount of time and the amount of data translation that we're doing. Many of the OEMs are sensitive to us referencing translated data as being the master data. So many times there's an extra step in the process that I've translated data from a CATIA model. Now I need to validate that the translated data is exactly what it should be, right? So we eliminate all of that by virtue of this solution. So managing translated data goes away since we're running natively inside of CATIA, which eliminates one step in the process and thus saving time. The next challenge that most people have, having access to model-based definition while creating the CMM program. So the solution that we demonstrated here today is that you're working inside of CATIA V5, which means that you can see any model-based definition, any FT&A that might be relevant to creating your program. Which the other benefit here is that it eliminates the need for extra drawings to highlight model-based definition for quality. Thirdly, need third-party application to validate translated data, kind of like I said a moment ago. Since you're working in CATIA V5, we don't need to translate data, so we've eliminated that one step in the engineering to quality process, which arguably is a non-value added step. And lastly, and I think that this is a big one for most people, a lot of people are looking at, to get some higher capability in quality, they're looking at upgrading CMM hardware or software and then potentially retraining operators. That could have a potential effect on throughput from a QA department standpoint. And most quality organizations are real sensitive to throughput because they do not want to be the bottleneck in the process, right? So this solution works with your existing hardware and software. There's no need to retrain the CMM operator. So basically, I'm going to do the CMM programming in the context of CATIA. I'm going to write it to the native file and pass it into quality, and that's what we're going to run with. So from a summary standpoint, we talked about the 3 takeaways at the beginning. Validate against native data. So what you saw was Larry working in the native CATIA V5 environment. He had access and visibility to any model-based definition data that was in the context of the 3D model while he was creating his program. And as we said, leveraging existing hardware and software without the need to upgrade. So as far as next steps go, consider your cause for doing nothing. I mean, at the end of the day, we could stay the course and do things the way that we're doing it today, and that's absolutely an option. We do offer quality process audits. So if you'd like to have somebody come in and who is a quality QA process expert from our organization, we certainly have those resources. And many times it's a few-hour kind of a visit. We can provide you a report back along with maybe some recommendations to help streamline some parts of your quality process. We also have an evaluation process. So if, based on what you saw today, it's something that you're a bit intrigued about and you'd like to give the solution a try, we'd love to have that conversation with you as well. So with that, let's open it up to Q&A, and I'll turn it back to Joni to read the questions that she has on her end. Go ahead, Joni.
Thank you, Frank. The first question goes along with 2 of them are the same. Does it support Calypso, Zeiss software, and how does this work with a Zeiss Prismo using Calypso software and a scanning probe head?
Yeah, I'll take that question, Joni. It does not, the scanning part of the Zeiss software, I'm not really familiar with. Keep in mind the post-processor settings can be customized. So just like any post, new posts can be added and posts can be edited, okay? We don't give you the tools to do that, but that's a service that we can offer to customize the post for you. As far as the Zeiss Calypso software, it presently does not post to the Zeiss Calypso. What it does do is it posts to DEMIS, and one of our large OEM customers in the South uses the same post processor in that other software I talked about, CAT CMM. It's the exact same post processor, and they take the DEMIS file, and Zeiss offers a DEMIS in, and so they create the inspection plan exactly the way I showed it, but it's in V4 instead of V5. They post the same post processor, and they take the DEMIS code and they read that into Calypso. It's been proven out. They've been doing it for about 3 years. So Zeiss offers a DEMIS read, which is, I think, a $1,000 option. So hopefully that answered the question. And it is possible to add a Zeiss post. That's one of the posts that we currently do not have, though.
Okay. Can you select the annotation versus selecting the actual feature?
Presently, no. Some future, we are working on one of the softwares that we're going to have another seminar on is called Inspection Expert for CATIA, It's AS9102 ballooning software. We are marrying these two products together. So the process will be you'll open up the CATIA model, you'll balloon the annotations and the dimensions in Inspection Expert. It'll create balloons. And then inside the V5 CMM Planner, there'll be an icon for inspecting Inspection Expert balloons. And if you want, instead of hitting that manual button where I put the tolerance in, you'll pick the balloon and it'll extract. It'll automatically name the point. It'll put a comment in there, inspect balloon 5. It'll grab the associative data, the tolerances from that. So it'll, for like a surface, it'll extract the profile tolerance. From a hole, it'll extract the diameter, size, and tolerance, and it will also extract the true position. So that's how the two are going to work, because the first step in creating an inspection plan is typically creating an AS9102 report. And again, we work very closely with Inspection Expert on that. So the two are going to be married together. Hopefully that answered the question.
Okay, and will this version up when CATIA does? In other words, V5 to V6 or R20 to R21? Yeah,
good question. We're currently supporting R19 and R20. R21 is coming out right now. As soon as customers start using R21, I have not heard anybody yet using R21. We will support R21. So this is a CAA tool, so we need to stay current with what the OEMs are using. And we are talking about putting this in V6. That's a little down the road because really no one's really using V6 a lot yet. I mean, that's the future, and there's 100% future plans that this will run in V6. But it rolls with the rev. So in probably, I would say, another sometime in Q2, quarter 2, we will be working in R21. Right now it's R19 and R20.
Also, will this planner allow to mirror for opposite hand parts?
Yes. In the post-processor setting that I showed you, you can mirror, and if I can demonstrate that, but you can mirror about the X, Y, Y, Z, or ZX plane. So you can create the program, and then you could post a left-hand part, and then mirror it, and you could post a right-hand part. And it mirrors the probe angles also to the geometry. So it does probe angles and the geometry. Very good question.
Actually, I think that is all of the questions, Larry.
I had about 3 that hit me over here. If I could read these off to you, Larry. We'll take maybe a couple more minutes. So the one question that came from Dennis asked how much training is involved for the product?
Well, I'll give you a real great history or a success story. We delivered this product to a large aerospace company last week, and I literally spent, I swear to God, 15 minutes with the guy. But he was an NC guy, or he was a CATIA NC guy. He literally, I spent 15 minutes, and he was creating programs. Because this feels a lot like CATIA NC. So for a CATIA NC guy, he's creating programs in the first few hours. Somebody that never ran CATIA before, I would recommend a 1-day basic CATIA class, and what Adaptive would teach is how to open up a model, how to create points, lines, planes, how to create a local coordinate system, how to turn on the annotation set, you know, just a basic 1-day class for somebody that's 3D literate and you know, is computer savvy. That way, then the planner, again, is another 4-hour deal. So somebody that never touched CATIA, you're probably looking at a day and a half, 2 days. Somebody that knows CATIA and they know CMM programming and or NC programming that's familiar with CATIA, 4 hours.
Okay, very good. Next question that I have came from Lewis. Lewis asked, can we create report templates, I think? Report templates, he's asking.
Yeah, what we do, can you show my screen again, Frank? What we're basically, very good question, Lewis, but what we're basically doing is we're outputting the data. We're outputting the data, and we're letting your native CMM create the report. So all we're doing, like in this case of a point, we're going to output that KC point, or if we get down here to holes, we're going to output the true position of the hole and the XYZ diameter of the hole. So again, that kind of goes back to what we talked about, the training curve on this. The CMM guy is doing exactly what he did the day before you implemented this. There's really no change. As far as custom reporting and stuff, we have some other CMM add-on tools that are Excel-based that we could talk about, so we could take the CMM report and we can go into Excel. We can do some best fitting. We can do some SPC, stuff like that. But as far as this tool, it just creates the native language that's going to create the report just like you're doing today.
Okay, very good. Thanks, Larry. We'll take maybe a couple more questions. We've got a question here from Mario. Mario is asking, how does the software handle a probe change, handle a probe change shape/size? Example, changing from a 3 millimeter probe to a 2 millimeter shank. Does that make sense?
Yeah. What that does, Mario, is we create right now, if you were going to, that's a very good question, actually. If you were going to, when you calibrate the probe, when the different angles calibrate, when you write the tip file, like I said, you're creating the different probe angle calibration. When you bring that in, let's say, I know Virtual DEMUS better than PC DEMUS, but if you bring that into Virtual DEMUS, and you could tell that that particular probe angle has a different length to it when you calibrate it around the cal ball, and the planner really doesn't care that you change the length. The only thing it would affect, and that's why this is a very good question, is for collision detection. How I would do that if I was going to probe some features with a different probe, I would have a different plan. So you can have multiple. Frank, are you still seeing my screen?
Yeah, we can see your screen. Go ahead.
You can have different plans. So this plan could be change probe size. And so there could be multiple plans. So you could run another plan and have another DEMUS code. So, but that's a very good question. Presently, it does not support that inside the same program. But when you do calibrate the probe angles, it'll be no difference. The only real effect inside CATIA, inside here, will be the simulation. It'll only show one probe. Now, if you change this, if you changed here to this, what you would do then is you'd come up when you run that plan for collision detection, and you would come in here and you'd build a different probe configuration. So when you launch this plan, it would show, let's say, a longer probe. And then while we're in this screen, I want to show that one question with post-processing. Here is where you mirror the program. So here's where you can mirror. So let's say I wanted the data on this program to mirror about the YZ plane, and we also mirror the probes. But that's a very good question.
Okay,
next, Frank.
Very good. Next one that I have here, and you may have already answered this one, I don't know. Danny asked if we can create multiple probe libraries.
Yes, in that probe builder, you can create, typically all you guys that run a CMM know the PH10 or PH9 doesn't change. You put a different extension before the TP20 or the TP2, a 2-inch one, a 4-inch one, or an 8-inch one, and then you change the probe tip size. there's only a couple pieces that change. You know, I've been running the CMM for 25 years. You know, you typically have, each guy has maybe 4 or 5 configurations that they use. So you could go ahead and build all these and save them inside the V5 Planner library and call them up anytime you want. Another very good question.
Okay. Well, we've got one more question here, Larry, and then we'll get wrapped up. This one, it's not clear to me who this came from, but the question is, how does it handle construction features, lines, intersect points, distances between, etc.?
Yeah, that's a good question. Presently, it doesn't do that. We would do that in the native software, but you can see on the bottom of my screen right here, construct plane, construct line, construct measure slot, sphere. So prismatic features are being tested and developed for this. So right now, this release does not support measuring planes and lines and slots and spheres. It is in the scope of things, but there's no reason that if you create 4 points and you're running PC-DEMIS and you measure those 4 points, you can always pull those 4 points into PC-DEMIS and construct the plane. So I want everybody to really understand one of the slides that we did. This is very geared towards model-based definition, this software. It's very, very powerful for putting exact points, name points, real fast probe changes, moving the probe around, measuring holes, working to the native model, working with the FT&A information. We're not really trying to replace PC-DEMIS or virtual DEMIS. We're trying to do a very powerful offline programming package that works from the native model, and it's going to get you 95% where you want to be. If there's a few constructions and things like that you want to do, you can always do that in your native software. So hopefully that answered the question.
Okay, so that's pretty much it on this end. So Larry, thank you very much. Great presentation. I'll turn it back over to Joni to wrap things up. Go ahead, Joni.
Thank you, Frank. Ladies and gentlemen, that concludes today's event. We thank you so much for your attendance today, and we hope to see you at our future events. You can see all of our listings on our website at www.adaptivecorp.com. Thanks again, and have a great day, everyone. Bye-bye now.